Well, ladies and gentlemen, welcome back to The Fanatical Futurists. My name is Freddie Clone, and today we are looking at the future of manufacturing and construction. The weird and wonderful world it is, from self-healing homes which can fix themselves from degradation, to the future of building skyscrapers, which is, of course, by 3D printing them, and also bio-mineralized fueled, self-replicating bricks. We've got it all for you today, but before we get into that, let's find out how our host, Matthew Griffin, is doing. You've been a busy man again, sir. What have you been up to?
So it's been literally a whirlwind. That's it. I mean, we started to calm down a little bit now before we start getting towards the end of the month. But I mean, the start of the week I was with UBS, so we kind of had a big investors meeting down in the city near Liverpool Street. So was having conversations really about the speed of change and the breadth of change, where we just went through everything. And I mean, it was literally a 12-minute sort of, I say keynote, but 12-minute presentation to about sort of 280 different investors that we had in the room. And at the end of it, they're all just going, "That's it. We've never seen anything like that. You know, well done, etc., etc., etc." So that was quite a surreal moment. Also, when you get sort of mobbed, frankly, by people who are investing, let's face it, a fair amount of money in a variety of different markets. And then we sort of had a nice dinner and everything else. And we sort of had probably 30-ish people basically around this ginormous table on the 8th floor, basically at UBS Tower. And the first questions that started being hurled at me basically was about fusion. Is fusion actually here? And we sort of had conversations through that. We talked about future of food, how we solve some of the United Nations SDGs and everything else, and then obviously things like cost of living crisis and inflation, and the CPI indexes, which sort of a little bit above my pay grade, frankly. But then earlier in the week, I was having conversations and sort of did some webinars with DLA Piper, which actually, so DLA Piper are a UK law firm. They're sort of one of what we call the magic circle. There are no laws protecting it. There are generally no regulations basically to shape or form it and everything else. And so actually, when you have a look at organizations like DLA Piper, Grant Thornton, Linklaters, Dentons, those kinds of guys, increasingly their role, along with government, obviously, basically is to actually help legalize the future. So that was kind of odd. And we sort of talked about future of food as it related to new legal precedents. So things like GMO crops. Ironically, when you actually have a look at gene editing technology like CRISPR, there are now a couple of companies in the US that have managed to genetically re-engineer different crops like cherries and kale and everything else. But because they haven't actually spliced the genomes of two species together, they have merely used genetic engineering to accelerate what would have been the natural evolution of these crops. These crops are not GMOs, which, I mean, that was a bit of a mind bender from my perspective. And that's from the FDA's perspective in the US. Which then means that has an impact from a legal perspective on things like plant variety rights. But then we talked about metaverse. So we obviously saw Hermes, basically, that released this new Meta Birkin bag a little while ago, and someone knocked it off and cloned it. So Hermes ended up sort of taking these people to court, and the lawyers basically went, "There's no precedence for this." We've seen companies like Cartier and Prada basically having their trademarks knocked off. We've also seen a lot of the sort of LVMH houses actually getting their trademarks in the metaverse registered by other third parties rather than themselves. So we sort of end up in kind of these weird areas. And actually, as I was sort of having a look into the area, basically, there was actually this really interesting piece of innovation that's come out of the legal sector. So we often think of the legal sector as being really ancient and antiquated, and kind of generally it is. We've got robo lawyers coming through and all that sort of stuff. However, some of the things that we've actually seen recently is if you have your Bitcoin stolen today, and you want to pursue the person who stole it, how do you do it? Because you've no idea basically who stole it. You don't have a physical name. You don't even have a location. You don't even generally have a continent of who just nicked your virtual stuff, your digital assets. Now, interestingly enough, in the UK, we've actually had two law firms that have, in that case, gone to court. So they've gone to the UK courts to get an injunction, and they've taken out an injunction to freeze the digital wallets of the people who've stolen cryptocurrency. Because we might not know who these people are, but we do have their digital wallet addresses. Now, this is the really interesting and forward-thinking sort of example that I've seen. This is probably the best example of how you deal with anonymous people across the internet. These law firms then served these court injunctions that they had on the digital wallets of the people who stole the Bitcoin, and these digital wallets are held on crypto exchanges. Those digital wallets were then frozen, and the court orders were served via NFT. So these lawyers essentially said, right, we know the unique number for the digital wallet that stole the Bitcoin.
Mm-hmm.
They airdropped an NFT into that digital wallet, which then meant the crypto exchange had to freeze the assets in that digital wallet. And in the first example of this, the person who stole this other person's Bitcoin ended up returning $1.8 million worth of Bitcoin.
Wow.
So ironically, the legal profession, I think, might have actually found a way to crack the anonymity problem that the cybersecurity industry has been grappling with. You know, when we have a look at things like ransomware and, you know, what we call attribution in that space. So I thought that, even though we sort of segued there, that's it. I thought that was just a phenomenal example of how a really, being mean to lawyers, antiquated industry like the legal industry can use bleeding edge emerging technology to solve a problem in a way that nobody else has actually figured out yet.
A couple of things that you mentioned there, Matthew. The metaverse and also sustainability, which are huge pillars, I know, of the future of manufacturing and construction, which we're going to be talking about on today's podcast. So do you want to kick off with learnings from the metaverse?
Yeah, absolutely. So I suppose, you know, when you actually have a look at the future of manufacturing, but also manufacturing and construction, you know, there's a lot more going on than a lot of people realize. You know, so for example, if we take it from the construction angle first, you know, we've got the development of 5G works. Now, 5G ultimately allows project managers on construction sites to automatically visualize what a building could look like from its digital files. You know, so you simply either put on a virtual reality headset, basically, or you put on, you know, some augmented reality smart glasses, or you use your smartphone, and you simply look at the site that you are standing at. You know, and you don't even have to be at the site, let's face it. But, you know, it's a little bit fun, basically. So a little bit funner being on a building site than, you know, being in a corporate office. But, you know, when you're actually sort of using these new tools, basically, you can actually see what the final building actually looks like. You can walk through it. You can see what assets basically have actually been used to build that building, you know, and all that kind of stuff. You can dissect it, you know, so this kind of, you can explode all these building information models up and out and everything else, you know. So we've kind of got that. Increasingly, we've got artificial intelligences really from Europe and the US, not so much Asia, that are now starting to, on the one hand, design rooms. We've got others that are designing entire buildings. And when I say designing, you know, you give them the parameters, and these AIs will say, is this the skyscraper that you would like to have produced? You know, but we've also got AIs that are now starting to design entire communities, but they tend to do this. This is kind of like an extension of the digital twin. So these AIs will design a new community really from scratch, you know, something that didn't exist before. But they will pull in all of this disparate data, you know, things like climate data, population and societal data, cultural data, you know, behaviors and patterns of movement data, transportation data, you know, utility data, et cetera, geological information. And, you know, what we'll actually see there is they will then sort of almost try to create the perfect community based on the parameters that you've fed into the model. So they will try to create the perfect community if you have told them to try to create the perfect community from a societal perspective. You know, whereas if you say to these systems, I want to maximize my return on investment for this particular building project, you know, what they'll probably do is create skyscrapers that are 300 kilometers tall, basically, where we're all living in ant boxes. You know? Yeah. So, so when you have a look at the use of artificial intelligence in things like, you know, architecture, parametric design, as well as, yeah, just the general design of communities and buildings and bits and bobs, you know, that's sort of quite interesting. But from a metaverse perspective, we can kind of now extend that out further, because when you have a look at Abu Dhabi, you have a look at Dubai, and when you actually have a look at Seoul in South Korea, a lot of us basically will know the benefits of having a digital twin of a city. You can model what goes on in that city in real time. You can then start trying to predict, if you do this, then this might happen to the city, from whether it's from a transportation perspective, a lifestyle and wellness or health perspective, mental health perspective, whatever. So you can sort of just do whatever you like, you can tinker. But while a lot of different governments are sort of turning smart cities increasingly into digital twins that they can then use to model energy data with, so for example, you can see which parts of your city are literally leaking energy basically from all their walls and everything else. And then you can figure out where you actually want to spend a lot of your time when it comes to new energy promotions and initiatives like insulation or solar panels or whatever it is you get up to. We're now starting to see, particularly these three cities, Abu Dhabi, Dubai, and Seoul, that are now starting to create what they call metaverse cities. So with Seoul, for example, they've just stumped up about $13 million to create the first metaverse city. Now, the reason for creating metaverse city in their particular case is because they want to be able to provide anyone anywhere with access to government services, such as, birth and death registrations, getting your tax done, getting your car license, your driver's license, or whatever it happens to be, as though you were actually there. So on the one hand, Seoul basically are kind of trying to sort of explore what the metaverse could actually do for citizens. But on the other hand, basically, they're actually really trying to see if the metaverse could help them increase the accessibility of different services. And then obviously we sort of pull in all of the usual energy information, et cetera, et cetera, et cetera. And we can do what we call metaverse digital twins, which go beyond just the plain old ability of a digital twin. So when we have a look at the metaverse, but that's sort of fairly interesting. And then when we actually start tying that into manufacturing itself, when we look at sort of continuous innovation, increasingly a lot of new products and services are actually being modeled in simulation first. These are generally digital simulations, like we think computational fluid dynamics and everything else. But as these virtual worlds get increasingly lifelike, realistic, as more of these worlds understand the laws of nature, the laws of physics, and so on and so forth, we can already see a point in time where your car, for example, that's packed with sensors, can stream information in real time across a 5G network to a creative artificial intelligence that is analyzing everything about that vehicle, from where it's been, where it's going, all the way through to the way that the vehicle is behaving. That creative artificial intelligence can figure that you're always driving through country roads that are full of potholes. Your car keeps going down into these potholes, and it's noticing that the shock absorbers on your car are just shot. You've gone into a pothole, you've cracked your shock absorber or whatever it happens to be. In digital time, they innovate a new axle that has been a digital copy of that new axle. Now, if you have a look at technology from companies like Siemens, you've got factory digital twins. This is kind of an Industry 4 play. But now what we can do is we can take the new product that the artificial intelligence has modeled, and the AI can now push this to the factory digital twin. BMW's got one. That factory digital twin can now involve the processes that need to be involved, the equipment and assets that need to be involved. It can even model basically things like the swing arm on the robots, the behaviors of the people basically who would be on the production line, while it's making this particular thing.
Yeah.
So anyway, the factory digital twin sort of says, right, in order to make this product, I have concluded that this is the most optimal factory setting. And once it's got that, the factory manager can, if they want to, can just push a button and manufacture that new part. And then that new part gets automatically fitted basically to the latest BMWs. And so when basically I'm now driving around those same potholed roads, especially in my new BMW, my axles don't crack. So this is where
Cool.
increasingly, when we have a look at the way that we can join all these different technologies together to create products that essentially design themselves, let alone products that can be continuously optimized and innovated in real time at very, very low cost. And those new models being pushed automatically to the manufacturing floor, whether it's robotic manufacturing, 3D printing, 4D printing, or molecular assemblers that we can talk about. When we have a look at 3D printing, for example, you can 3D print airplane parts as Airbus have, but as opposed to maybe creating a solid part, I mean, if we have a look at, say, for example, a wrench, just using a silly example, most wrenches today are a solid piece of metal. They weigh, I don't know what, 300, 400 grams, depending on what they are, a bit of a heavier wrench. But an AI basically will design the same style of wrench, but it might have a honeycomb interior, et cetera, et cetera, et cetera. So what it has is it has exactly the same tensile strength, but it's using up to 80% less material. When we actually have a look at the amount of raw materials that you need to 3D print a car, a vehicle, a tool, an aircraft, even trainers from Under Armour or Adidas or Nike, fundamentally, you don't need anywhere near the same amount of raw commodity resource or material that you would otherwise. I mean, even when we have a look at things like lithium-ion batteries, you can 3D print the anodes on a lithium-ion battery, but you can print at the nanoscale. Now, if you 3D print a lithium-ion battery at the nanoscale, you can massively increase the surface area of the anodes and the cathodes. And people are sort of be going, okay, fine, so what? Well, the so what is this? You end up with a battery with a massive internal surface area that now has 400% greater energy density than anything else that we've produced. And then I'm going to segue here to molecular assemblers, because a lot of people basically think that molecular assemblers are kind of a scientific, a sort of science fiction-like manufacturing technology. But sticking with lithium-ion batteries might sound a little bit boring, but you've got to take your hats off to Toyota and MIT. MIT a little while ago figured out a way to use viruses to assemble products. I mean, if you think about humans, we aren't made by robots, not yet. Let's face it. Hopefully never. Let's put that on there. But when we actually have a look at the human body, essentially we are a giant molecular assembler. What MIT and Toyota did is they figured out a way to use viruses to assemble products. And the first product that Toyota used viruses to assemble was a lithium-ion electric vehicle battery. We've also created DNA scale robots. So actually, DNA robots that are obviously DNA scale, and molecular robots. Now, with the molecular robots, researchers, and this is a couple of years old now, researchers put these molecular robots into a molecular-sized production line and then got them to assemble synthetic molecules. So, we've got the University of Glasgow has developed something called a ChemPuter, so chem for chemistry, pewter for computer, that is now essentially using the principles of molecular assemblers to create pharmaceutical grade drugs like ibuprofen, those sorts of things. So when we sort of think about the future of manufacturing, today basically we sort of think about robots, and I've got some stories about robots, particularly Google robots. That's a fun. I'll go into that in a minute. But, we think about robots, maybe. We think about robotic automation. Then we think about 3D printing. We might think about 4D printing. Now, when we have a look at 4D printing, we've actually got NASA who are trying to 4D print satellites and other space-like structures in low Earth orbit that self-assemble. So, all you do is you send up a block of materials And then a 3D printer will then start breaking all those down and go, is this the satellite that you wanted me to produce in low Earth orbit? And you go, yes, it is. Great. Wow. So we've actually got space-based manufacturing coming through now, not just with NASA, but also with organizations like Space Tango. So Space Tango, for the past year or so, have been launching sort of modules into space, which are fully autonomous. So not just automated, but fully autonomous space-based manufacturing centers, because there are advantages to being able to 3D print and assemble and or manufacture different products, like, for example, pharmaceuticals, basically materials actually in zero gravity environments and that sort of stuff. So, when we have a look at that, you sort of got this interesting segue. But when we sort of now have a look at robots, one of the biggest problems that manufacturers used to have with robots was you'd should we say program a robot to do one thing, and let's say, for example, that one thing that the robot had to do was maybe put a computer chip into your Apple smartphone, and we all know that robots basically could do that millions of times on the trot, never take a break. And, and it would be pretty much perfect all the time. Now, if you wanted that robot to do something else, maybe you wanted that robot to serve somebody a cup of tea for some random reason, you'd have to reprogram it. Now, to reprogram a factory robot, like the ones from ABB, for example, would cost about $50,000 and up. Which meant that if you wanted to repurpose your entire factory line of robots to do new things in new ways, you were paying a huge amount of money to reprogram them all and get them up and running and, et cetera, et cetera. Now, though, again, whether it's like, I've got a story from MIT. They have a robot called Baxter. You put on a skull cap as a human. You think about the actions that you would like Baxter, the robot, to do. So 1 minute it's putting computer chips onto a smartphone, the next it's serving someone tea without spilling it on them. And the robot telepathically learns what you want it to do. When you think of a particular action, you send out brain waves. Those brain waves are picked up by the skull cap that you're wearing. But in the future, we don't need a skull cap. You can just use a smart tattoo that's stuck on your neck, like a kid's decal, which maybe we'll do at the future of brain machine interfaces in another podcast. Mm-hmm. But anyway, the skull cap that you're wearing picks up your brain waves. The artificial intelligence within Baxter goes, right, if these are the brain waves that I'm detecting, then you probably want me to do this action, and off it goes. And then it learns it. So on the one hand, basically we can already telepathically retrain robots to do new things in new ways without having to actually reprogram them, not reprogramming them in the traditional sense. But this is where we now start going into a little bit more sort of Star Trek territory, because, everybody knows about the Borg. As Jean-Luc Picard says, the Borg basically are this single collective of machines and sort of cybernetic organisms and all that kind of stuff that operate a hive mind. Every node in the Borg knows everything. It knows everything that every other node knows. Mm. Now, a little while ago, Google, as part of their Everyday Robot project, figured out a way basically to use artificial intelligence and the cloud to essentially allow robots to create their own hive minds. Now, what this means is that if you have, say, 500,000 robots around the planet, you can teach one robot to do something, but that robot, because it's connected, I say to the internet, but connected to the cloud, can now pass that knowledge on to every single other connected robot. And so once you've taught one robot how to do something, that robot now, via a hive mind, teaches every other robot how to do that thing.
Through like digital osmosis almost.
Oh, absolutely, yeah. So what we have is we've got new ways to fundamentally retrain robots, whether it be in the factory. You can apply the hive mind to self-driving cars as well. If a self-driving car in Japan sees something new, but then figures out what that new thing is, via using hive mind constructs, there's no reason why it can't then communicate with a car in London and say, by the way, I just saw this shadow on the road and I kind of thought my machine vision systems initially thought it was a rock, but actually it wasn't because of X, Y, and Z. So if you see something similar, it's probably not a rock. You can drive over it. So this is, when we have a look at things like the future of the hive mind economy, that's where we get really into some really weird territory. And I've done the future of work lots and lots of times. And with some communities have actually touched on on the implications of a hive mind economy, which is a whole different story in itself. But when we start having a look at the future of manufacturing in these kinds of ways, robots are able to do lots of interesting new things along with drones. So in Dubai, basically, we are now starting to use drones to autonomously project, manage, and control drone equipment on construction sites. So in Dubai, they're actually trying to create essentially the world's first fully autonomous construction sites.
In general, though, for construction going forward, I mean, obviously, I remember 10 years ago working in advertising, working in a virtual reality, augmented reality little section of VCCP. And at that time, we just developed an app for IKEA where you could point it at your wall and show what a TV would look like in that space. But I mean, on a grander scale, how big a part is AR playing in the construction of, these cities, these bigger projects nowadays?
So more and more and more. And actually, I'll just sort of segue here. In Dubai, when we actually have a look at the future of construction, we've seen 1, 2, and 3-story buildings being 3D printed. But in Dubai, basically, they want to 3D print an 11-story skyscraper, which would actually be their second go at it, because the first company that they actually sort of asked to 3D print a skyscraper, if you go and actually kind of Google all of this, one of the founders seems to have embezzled all of the money. So I'll just leave that one there, so you can imagine. The first project designed to, and they were Khazar. The first project that was designed to 3D print a skyscraper in Dubai hasn't happened, doesn't look like it's ever going to happen, because humans got involved in the wrong way. So
someone's on holiday in Monaco with a big smile on their face.
Yeah, exactly. Yeah, that's it. Yeah, you can't extradite me, Governor.
No.
So when you have a look at the use of augmented reality, virtual reality, even sort of what we call MXR, where we start using haptics, et cetera, certainly a lot of the larger, sort of more forward-thinking, visionary construction companies and architects are actually using AR, VR, and MXR basically in their designs, basically to sort of not just actually sort of design the product originally, whether the product is maybe a, whatever it is, building, community, city, but also then to actually experience it, to toy around with it, basically to optimize it and all those kinds of things. But when we have a look at things like MXR, you've got things like the haptic suits and haptic gloves, basically from companies like Disney, but also companies like Tesla Suit, and there's lots more of these, where, increasingly, when we talk about virtual reality, yes, you can sort of see what the final building will look like in virtual reality, and you can walk into it, you can walk through it and everything else. But for me, one of the interesting things is, when we start combining sensory, what sort of mixed reality, this MXR construct, you could actually touch the wall, and so you can start seeing whether the wall is smooth or rough. So, which then, if you think about it from a design perspective, actually means that designers can suddenly just flip between different digital renders, basically for the interior lobby of their particular skyscraper. And, they actually then can start feeling that skyscraper from a tactical perspective or a tacit perspective. Which again sort of starts moving building design forwards. But then you start combining this with generative artificial intelligence as well as behavioral computing, where that and we see this with NVIDIA, for example, where an architect could be standing in the virtual reality lobby of a head office that they've just designed, but then using their voice, they could say, right, now put a pot plant in the corner, or take the wall that I'm looking at in the lobby and move it back 3 meters. Now curve it. So when we actually think about the process of architecting and designing these different buildings, from a sort of modern day perspective, a lot of the architects that I know, they still love their Wacom pens and all that kind of stuff, et cetera, et cetera. But when we have a look at younger generations, like my kids, when my kids, graduate in 10, 15 years time, if they want to actually design buildings, whether those are real buildings, in the real world, or whether those are virtual worlds in the metaverse, because we see Ernst & Young, for example, as well as companies like Accenture, who are building virtual reality sort of metaverse campuses and cities, basically, that they can take their clients to, take their clients into and sort of explore and everything else. Increasingly, the way that we design these will be in collaboration with generative artificial intelligences, where we say, I'm looking at a field. That field, I would like a 32-story skyscraper. I would like it to look modern. I would like it basically to have elements of Zaha Hadid in it, et cetera, et cetera. And the AI knows what you sort of mean, and it creates, say, for example, a Zaha Hadid-like, curvy building, or, whatever it happens to be. That's where I think all of a sudden, when you start thinking about being able to design buildings in that way that have any shape as well, that can then be 3D printed. A lot of skyscrapers, as well as regular buildings that we see today, if you look and think about houses, the houses that we all live in today are basically shoeboxes. They're cubes. But if I can 3D print a house or a skyscraper, I can 3D print it into any kind of design, any shape that I like. So this is where actually, when we have a look at the future of things like civil engineering, so actually, ironically, last week I was with a lot of the civil engineering community in London, and this might appear on the YouTube channel if I can get the video. I was talking about civil engineering in the year 2080. So that's 2080, because they wanted me to. And this is sort of where actually, from a future construction perspective, we were talking about the use of synthetic biology to grow skyscrapers. You take an acorn seed, you basically plant it in the field, and it grows your skyscraper. And when people sort of think, well, it's in, when we start thinking about the use of synthetic biology to grow a city or grow a skyscraper, people go, yeah, but that's nuts. And yet, when you have a look at nature makes giant redwoods from a seed. The only reason why we can't actually grow a skyscraper from, say, an acorn seed is because we don't yet know how nature controls the form and function to create of the stem cells and, all the different cells involved in growing a giant sequoia. But we do, ironically, and I showed this to the civil engineering teams. So we had sort of Atkins there and, the rest of the gang. This is sort of where, today we already have synthetic biologists who have managed to grow triangular cells or square cells. So they've managed to actually grow cells in particular shapes. And, when you start thinking about things like, the future of construction, we talk about 3D printing, we talk about autonomous buildings, autonomous project management, fully autonomous sites. We talk about, creative AIs that can collaborate with humans to create some really wonderful sort of future communities and cities and sort of, building designs and so on and so forth. I always think it was a fun little project that I sort of did. The thought that in 2080 we might just be able to actually grow a skyscraper like the Burj Khalifa, for example, for something along the lines of a futuristic acorn seed, seems like complete nuts sci-fi. But I can show you some of the people who are trying to create that future, albeit an incredibly generation 0.01 level.
But obviously that's 2080. Looking in the short term, or the shorter, near term, in the next couple of years, what is the one thing you're most excited about in the future of construction, which is within touching distance?
3D printed buildings. So there's a couple of reasons basically why I think this. So firstly, you can 3D print a building today about 80 to 90% faster than you can make a house in a traditional way. Now, 3D printed buildings today, you still need to put the glass in, you still need to put the plumbing and the electrics in and the tiles on the roof, but the ability to 3D print buildings basically today is actually really interesting. Now, in the future, we'll be able to 3D print buildings that automatically have electrics, plumbing, and smart home and control systems basically actually built in, sensors, printed into the walls and so on and so forth, as well as domed roofs. We've already got people 3D printing domed roofs. So when you have a look at 3D printed buildings, you can 3D print a building about 80 to 90% faster than you can make a traditional, say, 4-bed house today. You can also do it for about 60 to 80% less money, bearing in mind that buildings are very expensive. If you want to buy a home, anyone in a major city nowadays, basically, you need a second mortgage just to think about basically sort of, being able to afford a home. But when you have a look at some of the communities that we've 3D printed, we 3D printed a couple of communities in Mexico, basically, and those actually cost about $3,500 to print. These were sort of 2-story, these were 2-bed, single-story buildings. But interestingly enough, they were for actually the local farmers who pretty much had no money. So I think, when you have a look at 3D printed construction, that's very exciting because you can also get away from these boxes. I mean, how many people basically like housing estates, basically, or cities, basically, where you go, it's another box.
Yeah,
it's another box.
It could be the answer not only to be able to afford to build enough houses for people to actually live in, get out of living in people's basements and paying through the roof rent-wise, but also it can give birth to a new generation of actual design and interesting places to live.
Yeah. But also materials. So, for example, today basically we make buildings with concrete. Now we've got carbon negative and carbon neutral concrete coming through with a whole variety of different startups. We've actually got one coming out of University College of London, which is a carbon negative concrete, which sucks carbon dioxide out of the air to create essentially the aggregate that we then make the concrete with. Sort of different section. Maybe we should do a podcast on the future of materials. Yeah. But we've also got companies like Big and Icon who are 3D printing buildings with Lavacrete. You can also 3D print buildings using polymers. You can 3D print buildings using what we call biomineralization sort of materials, where if the 3D printed house starts cracking, maybe it gets a bit of subsidence, bacteria that are literally embedded into, not really the concrete, but embedded actually into the fabric of the house itself, are exposed to air, and then they react, form limestone, and then they seal the house. So you have self-healing homes, all that kind of stuff. Or self-healing, not self-sealing, self-healing homes. When we have a look at the materials that we can 3D print buildings with, we can already start 3D printing buildings that use carbon negative materials. In addition to that, because we're using 3D printing, it's easier for us to create carbon neutral homes as well, because you can use a material that during the day lets your building absorb long wave infrared radiation, for example. So that heats your house.
Yeah.
Now that your house is a little bit hot at night, because of the way that we've created and printed the material, that house can now emit heat in the form of near infrared wave radiation into space. So for me, basically, it's actually the combination of 3D printing, which helps us fundamentally design new buildings in new ways, but actually new materials that on the one hand help us create more sustainable forms of architecture that self-heal. In some cases, weird story. We have a biomineralized brick now, which contains sort of aggregate and all that kind of stuff, but also bacteria. You end up with bricks. So, you think of a standard brick that you use in a standard house today that replicate themselves. So this is where, I look at my desk and I've got one brick and it's made out of this biomineralized material. And then I look away and then I look down and now I've got two. It's kind of that funny. So again, sounds science fiction like, but actually you can, again, look at Google. Other search engines are available. Or look at the 311institute.com website and put in replicating brick and you can see a video of that. So yeah, so 3D printing
Crazy.
plus materials, plus creative artificial intelligences that can help you design your own homes and all that kind of stuff in different ways. And then we can talk about, sticking your home on the blockchain as an NFT and an LLC company, et cetera, which is maybe a topic on the future of real estate that we'll do later. There's lots of fun stuff going on.
There really is. Well, Matthew, thank you so much for enlightening, educating, entertaining us. That was absolutely wonderful as always. Let's just finish off by finding out what you're up to for the next couple of weeks before we speak again.
So I'm going to, just sort of try and actually have a little bit of time off. That's it, because I've been running absolutely ragged. Plus, we've had a lot of sort of curious family circumstances, basically, that, sort of won't go into. But let's just say everybody should maximize the time that they have on their planet wisely. Completely. That's it. And try to help one another, basically, in the right way, So I'm also going to be out over in the Middle East again in the next sort of couple of weeks, as well as the US, traveling around Europe a little bit. But actually, now starting to do a lot more in Asia as well. So going to be in Kuala Lumpur as well as Sydney and so on and so forth. So, I've got even though I'm sort of starting to try to wind down, basically there's still a lot that's actually going on. We're also launching in January we're actually launching and expanding our free university. So in the UK, schools in Hampshire are now going to be having the 311 Institute Futures curriculum rolled out to them all, which is very exciting. And we're going to be rolling that out to, because we've already done the trials. We did the trials sort of earlier this year. But we've now going to have sort of year 5 and upwards. So year 5 is kind of 10-year-olds and upwards. And I'm going to be teaching them all about the future, et cetera, et cetera. And, that's a very exciting project that I've got to do a lot of work on.
Well, Matthew, that sounds incredibly exciting as always. Good luck with your ventures, and I'm sure we will speak very, very soon. Thank you so much for giving us your incredible insight into the future of construction. And until we speak again, have a wonderful time and stay safe.
Cheers, Freddie. Take care,
Matthew.
everyone. Ta-da. Bye-bye.